Hello all, welcome to the Computer Vision video lecture series. In this video, we will explore the variety of image enhancement technique that can be performed using the OpenCV. So this image enhancement technique that comes under the mathematical operations on the image. So first we will see what is image enhancement. So image enhancement is the process of improving the quality and appearance of the image, and it can be used to correct the flaws or the defect in an image or to simply make an image more visually appealing. So some common goal of the image enhancement include the increasing the contrast, sharpness and the colorfulness, reducing the noise and blur, and correcting the distortion and the other defect. The second one is the adjusting brightness and the contrast. So the adjusting brightness and contrast of an image can significantly affect its visual appeal and effectiveness. It can also help to correct the defect or flaws in an image and make it more easier to see the details. So here we will be using cv2.add_weighted method. The next one is the enhancing the color in images. So here the color enhancement is adjusting the color in an image to make them more vibrant, balanced and natural. It can be used to correct the color defects or the problem in an image or to simply make an image more appealing and aesthetically pleasant. So the color enhancement techniques are adjusting the color balance, adjusting the saturation, adjusting the hue. So for that we will be using cv2.cvt color function. So which allow you to convert the image from one color space to the another. The next one is the equalizing the histogram. So it is a technique used to adjust the contrast of an image by spreading out the intensity values of the pixel in the images. So it can be important because it can improve the contrast and clarity of an image. So here there are several methods for performing the histogram equalization. So the first one is global histogram equalization. The second one is local histogram equalization. So this global histogram equalization, it adjusts the contrast of the entire image, while this local histogram equalization, it adjusts the contrast in small localized areas of the image. So again here we will be using the cv2.equalize hist function in OpenCV to equalize the histogram of an image. And the last is the image resizing and scaling. So image resizing and scaling involve adjusting the dimensions and the image of an size of an image. So we will see in Python all these operations one by one. So the first operation that we can see is the adjusting brightness and the contrast. So for this, first we are importing CV2 library, then we are importing matplotlib.pyplot as a PLT, then we are importing numpy as a NP. So here we have imported necessary libraries. After that, first we are loading the image. So I am loading this particular image and this image is in this path. So here I am using cv2.imread method, and that whatever image we are reading, that image is stored into this particular variable, that is the image variable. And now here what we will be doing, so this imread method is reading the image in the bgr format, and here we want to plot that with the help of that we want to show that image with the help of PLT, and PLT is showing the image which is in the RGB format. So for that purpose here I am converting that image. So this step is very important if you are using this two, that is plt.imshow, and if you are using that cv2.imread. So here what I am doing, cv2.cv2 color image. So this image is in the BGR format, this particular image. So I am converting that BGR into the RGB. Why? Because I am sure required the image is in the RGB format. So that's why I am doing this particular step. Then here I want to that show that show that image, original image. So let me run this. So here you can see this is the original image, and we have show that image in this in this particular way. So now the second one, what we want to adjust the brightness and the contrast of an image. So here what we will be doing, we will be adjusting that brightness value is equal to 12 to each pixel value, and here contrast is adjusted by scaling the pixel value by the 2.5, and you can adjust the value of that brightness and contrast to achieve the desired level of that brightness and the contrast. So here after that what we have used, I have used this cv2.add method, and for that I have passed our image, that is original image, then contrast value and brightness value, and this is what the image. After that again we are doing all this, and after that we are converting this for getting the image in the RGB format. So BGR to RGB we are converting, and then we are saving our image, and here we are plotting the image like converted image, brightness and contrast image. So let me run this again. So you can see this is the image with the applying effect of brightness and contrast. And you see here this is the original one, and here we have applied the brightness and contrast. So this is how you can apply the brightness and contrast values. After that, the another method for adjusting that brightness and contrast of an image is to use this one, that is cv2.convertScaleAbs method. So function which allow you to adjust the brightness and contrast using a combination of scaling and shifting the pixel values method. So here what I'll be doing, same code I have written over here. So you can see here I have loaded that same image, but only what I have done, I want to show you if you are not converting our that BGR image into the RGB, then what will happen. So that I want to show you. So that's why I have not written that conversion code over here. After that, I am just showing you. Now here what we will be using, here we will be using that convert scalab method. So here you can see for that convert scalab method what it required our image, that is the original image which is in the BGR. We have not converted here. So image is in the BGR format. Then alpha values we are passing. So here we have used that alpha value as the 1.5. So this value of 1.5 means contrast is increased by the 50%, and beta value we are using as a 50%. So here you can see this is the formula that we are going to use over here, and after that it actually it applies the formula that g of ij is equal to alpha into f of ij plus beta, and to each pixel in the image, where this f of ij is the pixel value and alpha is the contrast factor and beta is the brightness factor. So this function is doing that, and after that we are saving the image, that is brightness and contrast image, and just plotting. So here the same method is there, that is adjusting brightness and contrast, but with the different method, that is convert scalab method. So let me run this, and you can see this output, original and the brightness. So why, you can see our original image is like this, is in the blue color, but here we have not converted that into the RGB format. So IM read method is using reading the image but in the BGR format, and for plotting we required the image in the RGB. So that I have not done that conversion part, so that's why it is showing the different image. So if you are not using that, if you are not using that conversion method na, so it will be in the different color format, or in the you it might look the different in color. So that's why that conversion is needed. So this is how that original and brightness and contrast adjustment is done. The same code I have written after this, but only one method I have added, that is this one, that is CV2 color. That conversion I have done, other things are the similar one. You can see here convert scale abs method I have used here. So let me run this. You can see the original image and brightness and contrast image. So that's why we are converting our image, that is BGR image, into the RGB format. So this ensures that the color is displayed in the images are the accurate. Now we want to perform the next operation, that is enhancing the color in the images. So this color enhancement is the adjusting the color in an image to make them more vibrant, balanced and natural. So for that purpose we will be using that cvt color function. So here same we are performing, that is we are loading the image and we are displaying that original image, and after that what we are doing, we are converting the image from BGR to HSV color space. So here we are adjusting that hue, saturation, and the here you can see that HSV is nothing but we are adjusting the hue value by multiplying it with the 0 0.7. So you can see here adjusting hue. First we are adjusting the hue value. So in image this we are doing, and adjusting or multiplying it with by the 0 0.7. The second we are adjusting saturation by multiplying the 1.5, and the third one is the we are adjusting the value by multiplying it the 0 0.5. So here you can see that we have done, and after that we are converting our image back to the BGR color space. So initially we have converted into HSV, and by adjusting all these hue, saturation and values, again we are converting our HSV image into the BGR, and after that we are saving that image, and let me run this. So you can see here, this is the image, that is the original image and the enhanced image, that means after enhancing that HSV. So why our image, original image is in this color? Because initially when we have read the image, we have not converted into the RGB. So that's why it is showing like this. So again let me correct the code, and you can see here the second method I have used, that is the conversion, color code conversion. First we are loading the image, then we are converting into RGB, and then we are performing that operation like this. If again we are converting that RGB image into the HSV, and then we are adjusting the hue saturation values, then again we are converting our HSV value to the RGB value, and then here we are that writing that image. So again let me run, and you can see this is how our original image is, and after enhancing this is how it looks. Okay, so if you are not converting your image now, so that color might not be in proper. So that's why we are doing this. After that, the next operation is the equalizing the histogram. So this histogram equalization technique we are using for adjusting the contrast of an image by spreading out the intensity values of the pixel in an image. So again the same step we are doing. First we are loading the image, then we are converting that loaded image into the RGB. Then here we are displaying that our original image. Next one, what we are doing, we are converting our image to the grayscale, because for histogram, that equalize histogram function work only on the grayscale images. So that's why we are converting image into the grayscale. So here you can see cv2.color underscore bgr to gray we are using. After that we are using that equalize histogram method or the function, and for that we are passing our gray image, and here our equalized image is there, and then we are just uh, writing that method or saving and displaying. So let me run it, and you can see this is the original image and this is the equalized image. So if you want to equalize the histogram of a color image, now you will need to convert our image to the color space, and that separate the intensity values and then apply the histogram equalization uh, to the intensity channel. So you can then convert image back to the original color if desired. So this is how you can use the equalization histogram. So this is all about the image enhancement technique using OpenCV. Thank you.